Hi everyone, I'm Lavanya. This is the continuation of deadlock detection. Under deadlock detection, we have already seen what is the deadlock detection we are using for single instance of resources. For single instance of resources, as I have said, as such as deadlock avoidance, we are using resource allocation graph. For deadlock detection, we will be using wait for graph, and we have seen the construction of wait for graph. And second one is the multiple instance of resources. For multiple instance of resources, for deadlock avoidance, we have seen Banker's algorithm, right? In such a way, we will be using an deadlock detection algorithm for detection of deadlock in multiple instance of resources. The information which will be provided for this deadlock detection algorithm is allocation, available, and request. As said, available is nothing but it is the total number of resources which is getting allocated, which is available for each resource type. It is denoted by M. And allocation is nothing but the allocation matrix we have already seen. It is the current total resources which is getting allocated for each process. In that, allocation is represented by n cross m, whereas request is nothing but the additional number of resources instance which is requested by the process is indicated by the request matrix n cross m. In this, whereas request of I and j equal to k is the initialization for request matrix, whereas I denotes the ID of process, that is the process I is requesting for the resource rj of k instances. Okay, process I is requesting for the resource rj for k instance of resources. This is the meaning of this request of ij equal to k indication. Okay, this is the deadlock detection algorithm. As we have seen earlier, we have seen in safety algorithm, right, there are 4 steps followed. In deadlock detection also 4 steps will be recurrently followed. In this, the first step is allocation of work and finish vector, whereas first initially work equal to available, that is the available resources are allocated for work. In that, for the process of I instances, if allocation is not equal to 0, then finish of process equal to false. Otherwise, if allocation is equal to 0, then finish of process equal to true. This is the first initial step which we are allocating for the work and checking for the finish state. Okay, then the second step is followed by checking the value index for the process I in such a way, whereas finish of I equal to false, then request is less than or equal to work. Then if this is true, then it follows the step 3. Okay, if I exists, then step 3 will get followed. In step 3, we will be allocating work equal to work plus allocation, and followed by the finish vector I is equal to true. If it is true, then again we will be following the step 2. Okay, in this, the same finish of I equal to false, then the request is less than or equal to work is getting checked, and it gets repeated recurrently till I exists. It continues the step 2 and step 4. If no I exists, then it follows the step 4. Step 4 is nothing but finish of I equal to false, that is still finish of I is equal to true. Step 2 and step 3 will be run recurrently. If finish of I equal to false, then the system is in deadlock state. That is nothing but the process which requests for the resource is not available right now, and that resource is already getting held by another process. In that state, there is an occurrence of deadlock. So only it is indicated as finish of I equal to false, whereas the process Pi is in the deadlock state. This is the method of deadlock detection. Okay, that is only given in the problematic state. So in this, as we have seen, when the available is greater than request, we will be providing the resources. When available is less than request, we can't provide it, right? That is the condition which was checked early, when the request is less than or equal to work. Okay, if it is true, then the resource will get allocated, else resource will not be allocated. This is the usage of deadlock detection algorithm. Okay, if it is the cycle is forming in that graph, then there is a possibility of deadlock occurrence, and since how many cycles are getting formed, there is that much possibility of occurrence of deadlock in that system. Okay, this is the usage of deadlock detection algorithm.